This is a test wrapper for test 2, and I'm going to be going over one of the problems that I didn't do so well. So we'll just jump right in. So basically the situation we have going on is we have two wires going with current to the right, so one up here, one down here. And then we have two more, this one coming out of the page with 2I current, and this one going into the page with 3I. So it's just a multiple of each other, and basically we're going to be using that to decide the strength. The key mistake I made early on in this problem was I switched up the 2I and 3I in terms of the direction, and that caused all my answers to be backwards. But so now I understand that and can help explain further why this is really not that hard. So for the first one, we're going to be looking at point A. So these two are separated by 2s, and then this is separated by 4s. So we know that 2i is going to have a greater effect than 3i on point A, basically because it's closer by a factor of 2, but this is only bigger by a factor of 3. So 2i is basically going to trump any effects of 3i. And since it's in the middle, these two wires are going to cancel out as well in terms of the direction. So when we look at 2i, we can use right-hand rule. And we will see, like, your thumb will be pointing out of the page at you, and then your hand will be curling towards A, which is almost pushing A in a downward direction, which would be the negative Y direction. And that's the only force that's acting on it, because these two cancel out. So there you go. A is correct. 5 points. Easy. The next one, we're going to look at B. So B, the first direction we're going to discern here is it's closer to the top line. So basically, the top wire is going to have an effect on the direction of B. So we know the current's going to the right, so your thumb points to the right, and then you curl your fingers in, and you can see it almost pushing B down into the page, which would be the negative Z direction, which in fact is one of the directions. So from there, now we know it's negative Z, write that down, and we're going to look at the effects of 2i and 3i. B is sitting right in the middle of 2i and 3i, so we know 3i is going to be slightly more than 2i, but it's going to be going at an angle. So from that, you know it's going to be in the positive x and the positive y direction. And so we know from earlier we said negative z, so that's all three of those. The multiple choice is actually very confusing on this, but they're very understanding in the grading of that. So you would, I guess, circle positive x, positive y, and then potentially none of these because negative z is there, but just to be safe, best test taking practices says to write out negative z anyways, so that if there's any discrepancy, you can go back and do that later. So now we're going to look at point C. So point C is basically the same as point A, but the only effect it's going to have is the 3I current, which is going into the page. So your thumb points at C, and your hand wraps around and pushes down on C. So that is the negative Y direction as well, which makes sense. It's just on the opposite side that A and C are the same. So then the last part, which I actually got right, we'll go over anyways, and it's basically asking us on the x-axis, the net magnetic field is 0 at a distance from the wire with current 2I. What distance? So we're finding where it's 0. So basically we can use the magnetic field equations that we know and put in some arbitrary distance d, and we know that these two fields will add up from the 2i and the 3i to be 0 because it's in the middle. So here you can see we substitute in our current 2i and 3i, and then the distance from 3i, since we're doing this from 2i, is going to be 2s, the distance between, plus d. And that's the only difference. And then we know also that 1 is negative, 1 is positive. So now what we can do is solve for D. So basically you do the algebra there, and you see like things that cancel out, and you basically get 4i equals 6i over 2sd, and then you do basic algebra, and you come down and you get 4s as the final answer, where the point would be 0, which makes sense that there's a point such that the fields cancel out exactly, and that's exactly what you solved for. So really the problem isn't all that hard, very basic, and just has a few things going on that you need to keep straight in your head. In the future, I would recommend writing the things down as you go on the test, like this problem, writing them all out like that, and taking it step by step from the middle wires and the top wires. I think I got a little ahead of myself in the test and was not writing enough of these things down, and it really didn't help in the end there. But I definitely hope this can help you from making the same mistakes and clear some things up. Thanks so much.